Dr. Dan, me and Dylan just got back from playing our intramural soccer game. We lost horribly. I pulled a quad. Another player on our team pulled a quad.
I think I broke my index toe.
And Dylan broke a toe, but we're here still, right? Like, GVLs and assignment submissions take priority over our health and mental well-being. So here we are. Going to quickly recap our code submission here. We got the definitions for the new addresses. We looked through the datasheet. We found that FXD and 44 were the two that we needed. We define our read buffer up here with a size of 6. If we scroll on down here, you can see some of our code in setup has changed a little bit. We now have a nice little animation that makes the screen kind of turn on slowly. Dylan might show you that a little later. We will see. And then let's get into loop because this is where the magic happens. So we are going to be fetching the VCNL data from the breakout board right here before we do anything else, because this screen needs to be able to have the brightness and proximity detection no matter what screen it's on, right? So we do that here. Then we check if we should shut the screen off. We use the LCD sleep and wake up to actually fully shut the screen off and wake it back up again, as opposed to just bringing the brightness down. Then we check if the screen's not off, then everything else will happen, right? So you don't want the user to be able to, like if you had your phone pressed up against your face, you don't want any of the buttons to actually change screens or interact. So no interactions will happen while the screen is off. If the screen is not off, we will actually check if we need to dim it based off of the current brightness in the room. The darker the room, the darker the screen, right? So that's what that's going to be doing. This is getting it from that same VCNL sensor, which we use an array of sensor data information for. We use set LCD voltage as opposed to set brightness because the set brightness for us wasn't working, so we found that this worked much better. Same kind of screens as before, right? With zip screen and whatnot. The new screen, local screen, basically it will run a fetch local data and a fetch VCNL data, right, to get the information about the local environment, and then it will run it'll run the loop, and then when it is a valid loop, it will fetch the data. Actually, I believe it's actually yes, it fetches the data after every couple of seconds and displays that on the screen. The button B was pressed. Basically, this will take you to the zip screen, and if button A is pressed, it'll take you back to the weather screen. So you can navigate to any screen from any screen on the app. Fetch weather details. We've already gone over that. So let me scroll down to our local weather methods here, right? So this is the draw display. Super simple. We're just drawing a black screen, throwing some text on that with the temp and the humidity data. We can fetch the local data. This will actually read it from the sensors. I'll go over that in 1 second. And then same thing with the fetch VCNL data. If we go over to this screen, or this file here, the i2crw.cpp file, and we scroll down to the read SHT data, you can see it's very similar to the other function we wrote with the VCNL chip, but we have 6 wire reads as opposed to just the 2, I believe, from the other one for the 6 bytes. We also had to move this delay above the verbose to make sure that it did not give us an error while reading. And that about wraps that up. We found these in the datasheet documentation. So these are the conversions for temperature and humidity. And then we set those equal to the return buffer at 0, return buffer at 1. We end the transmission, and then we return those 2 values in an array of 2. Poop buffer is just a funny name we have of the default array. If some error happens or something and we need to return just a null value, so we always return something. But that wraps up the code review. I think we had like 1 or 2 more small changes in here just to defining those read SHT data functions and whatnot. But yeah, thanks, Dr. Dan. I'm going to pass it off to Dylan to do the hardware.
What's up, Dr. Dan? We're going to show you this dope thing that we integrated into this like some studious software engineers. Woo-hoo-hoo-hoo. Loading from dark to light. Guarantee you didn't think we could do that. Now we are loading. Jake implemented this dope loading screen while it's getting the API data, so the user's not just staring at a blank screen. You know, we're part of that UI UX crew. Wow, it's taken quite a while. Using them async awaits, React Native. No, I'm just playing. Boop doop. Okay. Dang, this is taking forever. Oh, look good up in there. God, this thing is taking forever. Oh. Oh. Ah, it's reloading. API must be down. Oh, great. Man, I shouldn't have pressed refresh. Jake told me not to as well. Okay, so now we're here. And as you can see, it's like kind of getting darker. Like you see my finger. Ooh. 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 Oh. Dang, this is an iPhone if you could say that. Alrighty. So now we're going to come over here. As you can see, we can still go Celsius to Fahrenheit like gangsters. Come over here. We just attempted this one, so hopefully it doesn't break it again. If it does, Jake will probably get mad. This is take 4, just so you know. 6, 7, 8, 1, 2, 3, 4. Alrighty, come back over to here. See, these buttons are so hit or miss. You just gotta get lucky with them. Ooh, big finger hit it. Okay, so now we're in Menifee. And if you switch to Celsius, come back over to here, and come back over to here. Come on, bro. Okay. Just gotta get lucky. There we go. You should see it is still in Celsius. So now you can't mark us down 10%. So now we're gonna go over to what we were actually supposed to do. Well, bam! Local data screen. And this is our, is it this one? No, it's this one, the SHT. So the SHT is getting our temperature. So as you can see, if I put my fingers on it, it'll reload. You see it's getting hotter and hotter. And as you can see, we have a timestamp down here tracking that time. So now if we come back over to here, you saw that it was in Celsius. We switch it to Fahrenheit, come back. My fingers were 109 degrees Fahrenheit, so my hands are on fire right now. And Jake, can you pull up the spec sheet to make sure I get everything?
Absolutely, Dylan. Let me pull this up for you.
We just have to make sure that
Real
we get
quick.
everything.
Yeah, you never know these days with Dr. Dan's assignments,
Yeah.
Let me pull that up. Where the heck did that PDF go, Dylan?
I airdropped it to you, bro.
I saw that, but like it got saved.
Do you think if I leave this recording, it'll stop recording?
No, I should.
And we're back from the commercial break. So, as you can see, there was no spec saying we had to be able to click a button over here to convert it to Fahrenheit Celsius. So we did do that over here. Hey, Jake. Don't do that.
Sorry.
So now we can convert it to Celsius. Come over here and you see Celsius. And then, alright, so you see how Jake's got his bright light. The screen's real bright. It's blinding my eyes. Now it's getting darker. And as you put your hand over it, it dims. And then, well, bam, it shuts off. Oh, straight back to, oh, alrighty. And I believe, let me just double show this again just to show that we're doing it right. So as you can see, we have a timestamp. Where's it gonna go? Oh, there we go. So you can see the temperature and humidity is increasing as my chubby fingers are holding the sensor, and the timestamp is updating for each time that we get a new time. Now, if we come back over here, once again, we're at Celsius. We'll just switch back to Fahrenheit for fun one more time. Come over here. Well, bam, Fahrenheit, local data screen. And guess what? We're still in Menifee. Thank you, Dr. Dan.